Hi everyone, welcome back to Petroleum Transport and Storage Engineering. Well, we have completed the first part. We talked about the transportation via the oil, mainly via the transportation of oil via the pipelines. Mainly, we talked about it, and now we are going to talk about the petroleum storage tanks. What are those? What kind of storage tanks we have available, and after that, we'll talk about the measurements, how we measure, and so on, and further detail of the storage tanks. Well, first of all, we have to understand the terminology here, which is we call it as an oil terminals. What are the oil terminals? Well, oil terminals is a place where we have lots of storages for oil and gas. So when we store, let's say we have two or three storage tanks, big storage tanks, we call it as an oil terminal. It's as simple. So how we define it? We define it that is a place to store various liquids and gases. Okay, and these oil terminals are important. For example, you have oil. You are producing oil from 10 wells. Where you will put them? You have to where you will put them. You have to save this oil somewhere, store this oil somewhere before you send it to somewhere. So every oil field you have, it has some storage tanks. One, two, three, depending on the capacity of the reservoir, how much oil you are producing a day. Okay, when you are sending this through the pipeline, before the pipeline you need storages wherever your transmission pipelines are. Okay, then when you are dispatching and the customer is receiving, again he's storing it somewhere. So oil terminals are vital. So oil and the storages are needed right now everywhere in reservoir and oil fields, in for the pipeline, in customers area, and in the refineries where the oil is processed and so on. Right now, as you know, the oil price has declined around 10 to $11 per barrel WTI, and the speculations are that when these oil storages are full around the world, then there will be no space and oil will be more cheaper than what we have now. Even in fact, I saw the a news yesterday on oilprice.com that they want to convert the oil pipelines into the storage in the end. For example, if there's a transmission pipeline from one place to another place, so if there's no buyer, they want to keep the oil inside the pipeline also to store it there. So that's why this is oil terminals are important everywhere. Now, what is the storage tank? You see here these tanks, and how many tanks? This is a big oil terminal that here we have it. Big oil terminal. Here you can see we have a big oil terminal. We have it here. Here we have it. Okay, and it can store oil, and you see we have a ship. So actually this ship either has brought the oil so that they are filling these tanks, or these tanks storage oil is going from these tanks to this ship to go to the another country. It's carried so these are basically the processes going on around the world for the, but in Kurdistan this is not applicable because in Kurdistan we don't have any seaport like this one. So what we have only tanker transportation through these storages and so on. So what kind of products we can store actually? We can store the crude oil mainly. Okay, we can mainly store crude oil. But this crude oil, as you know, we always divide into the light, medium, and heavy crude oil. Each kind of crude oil needs a different kind of storages that we are going to discuss here in this lecture. Then after the refinery process, you have gasoline, diesel fuels, and aviation fuels. This gasoline motor, for example, you go out here, you have lots of fuel station here in Suleimania, and these fuel stations, the oil, the gasoline that you put for your car, actually it is stored somewhere. These are they put these storage tanks underground. You don't see them, but they are there with safety and all the features there. And also they need big storages. Okay. Then the natural gas liquids, propane, butane, condensates, they also need their storage. So we have lots of products that we can store in these storage tanks. Now, the question is what kind of storage tanks we have available. We have six basic types. Okay, we have fixed roof, and we have floating roof. We have doomed external. We have internal floating, variable vapor, and pressure. Well, we have six different types, and all types they have their own products and so on. Each type, for example, I tell you here, if you are dealing with the light crude oil, and light crude oil has lots of vapors. In this case, if you use the fixed roof, well, you will lose your product. You cannot keep the light very light, which has very high vapors. amount of vapor cannot be kept in the fixed roof. Or you have the the any other kind of crude oil, for example, it's very heavy crude oil. So sometimes you need a heated or insulation. Or there's another kind, for example, LNG, as we discussed in the last lecture. You want to store the LNG. Now LNG needs a temperature of minus 161 degrees centigrade. So you cannot use the simple atmospheric tanks. You have to use the cryogenic tanks, so on. So how do we classify? For example, if we have the tank, okay, if we make a tank here like this one, how do we classify these tanks? Well, we have to look at what is the pressure here inside. Okay, is it the atmospheric or low pressure or very high pressure? For example, there are crude oil, we need very high pressure for them. There are crude oil we can keep at atmospheric pressure, or some of them at low pressure. So depend on the product, what kind of storages you need here in this case. Then the atmospheric, what are the types of atmospheric uh, storage tanks? For the atmospheric storage, and we have fixed roof, vertical and horizontal. I will show you all of them in a videos, in a very nice real pictures and videos of these one. So atmospheric one has three different kinds: fixed roof, vertical and horizontal, and floating. Fixed and floating, they both are used for normal pressured storages. Then we have pressurized. Okay, if you are transporting variable vapor, when there's a place for variable vapor, you need a very high pressure or low pressure, so we have pressurized tanks. Then we have heating tanks, which is used for high viscosity, when you are dealing with a very heavy viscous oil which is very hard to flow, and you need a heat uh, to reduce its viscosity and move on. So in this case you use the heated tanks. Then we have the refrigerated cryogenic tanks. In case for LNG, you need the cryogenic and refrigerated tanks. So let's discuss one by one and how they work. Let's talk about first of all the open roof and the atmospheric tanks, fixed roof tanks. Okay, these flash tanks are for hydrocarbon liquid with very high flash points. Okay, and from the picture you can see the way the shape is made. It tells you that which kind of storage tank it is. So for example here, this one, this is an atmospheric tank, and very clear picture of atmospheric tank. And how it shows, it has a cone roof. It makes a cone like this one, or the dome like, or umbrella roof. So this is, you see, it's like an umbrella roof also here. Okay, so if there are losses in the fixed tank, they are caused because of change on temperature, pressure and liquid level. These are the reasons for the fixed tank. Here they have the floating roof. In the floating roof, we have the cap. We have the cap, and the cap moves ups and down. Up and down. It's like a piston which is moves ups and down. Ups and down. So we call it a float. Actually, it floats according to the level of liquid. For example, this is the size of the tank, and if the liquid is still here, okay, till here, then this top of the roof will come down and fix it here. So I will show you in a video how actually it looks like. For example, this is the level of the video, and this is the level of the liquid. So the roof is actually floating. Floating means moving from up and down. So when you have low liquid, it will come and stay here. If you have high liquid, the roof will go up. So it's actually floating. Here you can see that this is actually floating. So now I will show you some of the examples of roof fixed and roof type videos storages here.
About storage, starting with tanks. So this first slide shows that in many of our tanks we actually have a roof that floats on top of the fluid as the fluid goes up and down. So if you look at the left, it shows you if we had a tank, just a standard steel tank with liquid in it, then we'd have a surface, and on the top would be vapor. So the materials, the gasoline, diesel, crude oil, would vaporize and come to the surface. So in order to keep this from happening as much, we have a roof on the top, and this probably this started a number of years ago from a regulatory requirement, probably in the 70s. Not required to have a roof on all surfaces or all fluids. It depends on the vapor pressure of the fluid, but very common to have a roof, and so it floats up and down, and above the roof there's no vapor, but there's less vapor than there would be if we didn't have a roof. So we have floating roofs on a lot of our atmospheric storage tanks. Picture of a couple tanks here, very standard in a refined products terminal. If you look on the left, we have an external floating roof tank, EFR, And over here on the right, we have a cone roof with an internal floating roof, an IFR. So if you look at this cone roof tank, you can see up here there are little openings that looks like vents. And those are what they are. They're vents so that whenever the roof that's in this tank floats up and down, if it comes down, it can allow air to be drawn in. If it comes up, then whatever's above the roof will be displaced out. Now, one thing that happens on about a 5-year frequency, something like that, is people are having these tanks painted, and the painters will tape up these vents, and somebody will forget to tell the central control room that they shouldn't operate that tank, and they'll begin to take suction from the tank, and the level of the fluid in the tank falls. The roof goes down, creating a vacuum, and then the tank is sucked in. I was teaching this class, classroom instructor-led training last year, and a fellow said, yeah, we had that happen just the other year. So one of the little watch-outs you need to have, so external floating roof tanks and internal floating roof tanks.
Sanborn Roofs offers unmatched quality and value with the Sanborn Floating Roof System. Sanborn Roofs has been manufacturing and installing API 650 compliant full contact internal floating roof systems since 1979, with hundreds of installations servicing oil and gas producers in North America and around the globe. Sanborn offers custom-designed inlet diffusers to limit inlet velocities and meet API standards and recommended practices. Our pressure-actuated vents allow venting during the initial flotation of the floating roof, as well as dissipation of any vapor purges during normal tank operation. The innovative design of the Sanborn floating roof allows our clients to maximize the operating parameters of their storage tanks. Automatic combination pressure and vacuum relief manways are standard components on the Sanborn floating roof system. The basic building block of the Sanborn floating roof system is the self-contained flotation module, which is composed of a closed-cell composite polyurethane foam core, treated with a fire retardant and enclosed in a copolymer-coated aluminum skin. An optional stainless steel module is available for elevated operating temperatures and high abrasion applications. The Sanborn system can be installed through a standard 24-inch diameter shell manway. However, we are capable of installing through a 20-inch opening with a special module if required. The heated seal joints of each module are then reinforced with flat bar and stainless steel screws driven into the encased framework. Angle members are then placed perpendicular to the main flat bar to provide lateral strength. The deck perimeter is bordered by aluminum perimeter plates and channels, which provide additional rigidity to the edge of the deck and allow us to mount the rim seal, such as our mechanical mini shoe seal, double wiper seal, or combination shoe seal with secondary wiper for added efficiency. We incorporate a number of high-efficiency seal systems for deck penetrations like internal ladders and columns. Our penetration seals come in either single wiper or double wiper with a fabric curtain, and always include guide rollers to reduce wear and tear on seal materials to keep the seal operating at peak efficiency. Each Sanborn floating roof system has been specifically designed to eliminate the problem of static buildup. All surfaces of the deck are metal clad, interconnected and grounded to the tank. The Sanborn floating roof system offers unmatched emission control when compared. A Sanborn low-profile internal floating roof results in increased tank volume when compared to an internal steel floating roof. When further compared to an external floating roof tank, the Sanborn floating roof system is able to offer superior tank capacity and emission control. Additional services provided by Sanborn are external floating roof tank seals, drains, and fire foam systems, internal floating roof repairs, seals, retrofits, and maintenance, CCME compliant inspections and reports. To learn more about Sanborn floating roof systems or any of our other products or services, please contact us.
external floating. So actually, as I showed you in a video, that this one actually moves up and down. That's the main one. This is the doom one. This has the external. So this their external one, the top one actually moves up and down. The internal one is this is the external. So whatever at the top, it actually moves up and down. That's like as I showed you in a video. And the internal one, it has two: external fixed one, and there's the fixed, the moving one, which is inside. So it has two times. It has benefit. It reduces the rate of evaporation. So if there are vapors, it's very good one. But of course, it's a cost. Then, as I said, for refinery where we have a very highly flammable one, as I showed you, for example, you want to keep liquefied hydrogen here. So this is the one we can use as a pressurized tank here. And its shape is interesting because it's like a ball here. Then we have variable vapor one. For example, if we have lots of fluctuation in vapors, sometime up, sometime down, then there's a variable vapor one, kind of a roof tank here. So these are the types of roof tanks here. But make sure that each tank that you, it has lots of other system also. Because for example, make sure that it has the leak detection system. Maybe there are some leakages of vapors or something. So we have to be very careful for this one. Then we have the uh, system which tells us how much fluid is inside. So it tells us actually. So if loss occurs, fluid like a decrease, we need a floating roof is decreased, and we need an alarm if there's a loss occur or liquid level is decreasing. So we follow it all the time in manual. Okay. Then the standards that we follow to make these tanks, we have A1 construction standards, inspection standard, recommended practices, how we operate them, and other API. So these are the A1 API standards, A1, A2, A3, A4 that you can follow for designing, operating, maintenance, and production. Well, whenever you have above storage tanks, you need to follow some government regulations at the same time. At the same time, the company policy, the government regulation, all the safety standards of the EIA agency, Environmental Impact Assessment Agency also. Make sure that the tank you are designing, uh, it should have and leak detection system. Leak detection system. It should have a secondary containment. I will discuss in the next slide what is secondary containment. Secondary containment is actually is like of a wall around the tank, which helps us to avoid if any spill happens. Then secondary containment, it will be in that area. It will not go out of it. So we make sure that there is a proper distance between the storage tanks. There is a proper safety. The people who are operating them, they wear proper PPEs, and there is proper leakage system, proper corrosion system. We monitor their thickness. We make sure that nothing goes wrong in the diameter of those pipelines, those storage tanks. Now, what is bund or secondary containment? This is the secondary containment. So we have a storage tank, and then on the side there is a wall. What happens if something happens to the storage tank? Some leakages happen. Some leakage happen from here or this one. So whatever the oil will spill, it will be still inside this one, like above. It will not come out of it. So this is the requirement. So any storage tank you make a secondary wall here around it, so that if any spill happens, it stays inside, does not pollute all the area. And if you cannot design the properly the storage tank, there's a big issue of this fire and blast and so on. So there are a lot of problems if they are not designed properly, and if they are not operating in a safe way, so it can do lots of disasters. When you design the tank, you have to look at the design ports, location of what are the, as I said, API A1, A2, A3. You have to follow all of them. The tank location, you have to follow the tank location. Capacity of the tank and diameter, the pressures of the tank, filling and emptying tank, operating pressure, operating temperature, density. You have to take care of, consider everything when you design them. These are the requirements. So when you design the tanking working pressure, this is the equation, which is based on temperature and so on. So now I will show you some more videos about these storage tanks, which gives you a very clear idea about the petroleum storage.
So what's the plan? War.
So this is the oil terminal here. It has 5 storages here, 3 here, and 5, 6 smaller ones.
Sunday 11th of December 2005. A large explosion occurred at the Bunsfield Oil Storage Depot near Hemel Hempstead, Hertfordshire, followed by a huge fire.
Look at the storage.
Fortunately, there were no fatalities, but 43 people were injured and significant damage occurred to both commercial and residential properties in the vicinity. In January 2006, the Health and Safety Commission appointed 6 individuals representing the Bunsfield Major Incident Investigation Board to oversee the formal investigation into the Bunsfield accident, which was performed jointly by the Health and Safety Executive and the Environmental Agency. The investigation determined that a flammable cloud was formed by overfilling and spillage of some 300 tons of unleaded petrol from a big storage tank, which was subsequently ignited, resulting in the explosion.
Overfilling was the reason for this one, and this is another video of the same.
December the 11th, 2005.
Emergency. Hello, can I have the fire engines, please? What's wrong? It's on Maylands Avenue. There's been an explosion. I live on Mason's Road, and it's at the house that I look onto.
There's been a huge explosion near Hemel Hempstead in Hertfordshire. It happened at Bunsfield Oil Depot at 6 o'clock this morning.
There we were driving along what appeared to be like a normal estate, industrial estate, and then suddenly you go around a corner and you were in a scene of complete devastation, like something out of a science fiction film, with cars overturned, buildings blown in, with all the windows gone.
It's exactly a decade since the largest ever explosion in peacetime Europe. Early in the morning on December the 11th, the Bunsfield oil depot blast rocked businesses and homes and had a lasting impact on the way companies deal with safety procedures. Miraculously, no one was killed in the blast or the 3-day fire which followed, after vapour from thousands of gallons of petrol ignited.
Emergency. About 25 minutes ago, we all heard a phenomenal explosion, and there's flames and clouds.
There's been a huge explosion. I think it's 3 Cherry Trees Lane, Woodhall Farm, Hemel Hempstead. Huge explosion.
We had an explosion about a quarter of an hour ago.
I can hear car alarms going off. I would say it looked like there was some smoke coming over towards the southern side of Harpenden.
In this Bob FM News special, we'll hear from the people directly affected, as well as the emergency services whose response to major incidents has been shaped by the disaster. Hertfordshire's Chief Fire Officer Roy Wilshire was Gold Commander on the morning, meaning he oversaw the unprecedented emergency response.
As a Chief Fire Officer, you don't get many phone calls in the middle of the night anymore. So when you do get one, you know it's something serious. So I got a call probably about 6:10, a few minutes after these.
We're attempting to 804. It's 110-foot diameter tank, and it's got an internal floating roof, which is in need of repair. That's the reason behind the 440-ton crane behind us here, to attempt to lift this thing out and set it on blocks. We'll have cribbing in behind us where the roof will be lifted out and set down on the cribbing.
Okay, so that's all for today's lecture, and now we will talk about the measurements, how the measurements are done inside these storage tanks. So see you in the next lecture.